Hey there, this is Ralph, and in this video we are going to practice a little bit of Excel. However, we're going to do things that are a little bit trickier and more challenging than what we did in the previous week of Excel. We're going over the basics. So our focus here is using Excel to solve problems. And they can be all kinds of problems, but typically they might be more, let's say, financial or economics related problems, things with data. But pretty much any field that uses data in Excel, you can use problem-solving techniques and thought processes in order to make those decisions easier and hopefully more effective. Now, I do have a PowerPoint for this particular module, but as I scroll through, you can see that practically, in fact, might as well safely say all of the slides are empty. They just have some key labels and titles. So I'm still in the process of producing this presentation. However, it's mostly just going to be some screen captures of finished products. And I want you to use this PowerPoint just as kind of a quick overview for many of the skills you might take care of as you're working on several Excel chapters in your book. Chapters 3, 4, and 5. You've already gone through 1 and 2 in quite a lot of detail, so I'm imagining you're very well versed in those particular topics. So you're studying these chapters. Now we've actually done a few little skills in here already, but I want to hit them a little bit harder. Now in this particular video, just really trying to encourage you to get into our Excel topic, and I'm going to pick on a couple of things here to do later in the presentation. So I'll work on some stuff with you. I'd like you to do this as well. And then, of course, we can, or I can take screen captures and put them into the PowerPoint, and then I can do other screen captures later off camera, so that way it's a little bit more of a reference or resource for you. But don't forget, I want you reading and practicing, and while you're reading, have Excel open so you can get some hands-on practice as you are reading about it. All right, let's see. I'm going to jump down here. So I'm going to look at payment function, calculating total interest. I might skip over creating a date. Actually, no, I'm not really skipping over creating a data table. I'll do a data table, but really I'm going to do an amortization table since that's on there. Data table, amortization table, very, very similar. And maybe we'll throw in some conditional formatting as well. So we'll get a few topics on here. The amortization table is probably going to be the trickiest of the lot. And you've already seen some specific videos on the payment function, so I know you can do that. And calculating total interest. So let's go ahead and get to it. I have Excel open, and I guess I will go ahead and Control S to save. Scratch that. Okay, so it looks like I'll just be going to browse, and I'll just stick this in my downloads folder. Good enough. All right, annoying. Okay, I guess I'll just try doing some work here. Okay, the first thing on our agenda is a payment function, which you've seen before. So let's make this look kind of nice and neat. I'm just going to double click on my sheet tab down in the lower left, and I'll type in PMT as a note that this is my payment function. And I'm going to do this with a house. So starting off in cell A1, I'm going to keep track of the house price, pressing my enter key. Then I'm going to go down to a down payment, enter. Then I'm going to do the mortgage amount. That's the loan that you get. The price minus the down payment means you have to borrow the excess. And let's see, I'm going to put in number of years, enter, the interest rate for the loan, and then we will calculate the monthly payment using the PMT function. But I'm also going to go ahead and put in total paid, and then the finance cost of financing. I'm going to make this column a little bit wider. I'll go ahead and do that. And I'm going to zoom in just a little bit more on my spreadsheet just so I get more stuff included on there. And let's see what we've got. So we've got a few pieces of some text labels. We need to enter in some information. Now I know we've done this one before. We've done it in class, or you've seen me do this as part of another video. So I'll go kind of quick on this particular version. But let's go ahead and take care of some of our details. For the house price, I'm going to go ahead and put in, let's do $480,000. That's probably close to the median house price in Bend, Oregon. And for down payment, I'm going to put a formula in here. I'm going to take my house price and multiply that by 0.20, which is 20%. And so we've got that in there. The mortgage amount is going to be equal to the price of the house minus that down payment. Remember, don't do the math in your head. Always write formulas in Excel so that you can easily change things around. So if I want to change out my house price, I know my down payment and my mortgage amount are going to be instantly calculated for me. Now, of course, the down payment, you might actually want to put a hard number in there, so instead of using a formula, which makes sense for sure. So maybe instead of 96,000, I'll just handwrite 100,000. In fact, that'll give me the opportunity to more easily show you the goal seek feature as well, which is another one of those PowerPoint slides that I need to have some content for. Okay, number of years, I'm going to go ahead and type a 30 in there. Most mortgages are 30-year loans. Interest rate, I'm going to go ahead and put in 6.7%. That might be the going rate right now for a 30-year mortgage. And for the monthly payment, we need to calculate that with the payment function. And then after we do that, we can calculate the total paid and the cost of financing. Okay, well, let's see. I'm going to go ahead and select several of these cells. I'm going to make them accounting, get rid of the decimals, don't need those. I'm going to go ahead and click on one of them, choose my format painter, and I'm going to select these other monetary cells so that I know they're going to be formatted in a similar way. Well, let's get to it. I'm going to zoom in even more since we're focused on this payment function. And I'm going to write equals PMT. And I press my tab key, and that puts in my opening parentheses and or finishes my function name once I've selected it. And of course, I'm always looking at that screen tip to remind me what I need to do next. So the rate is what it wants to know first. I click on the cell that contains my mortgage interest rate, and I divide that by 12 to get it into monthly terms, comma. Now I'm going to click on the cell that contains the number of years, and I'm going to multiply that by 12 to get the number of months. So 30 years, how many months? I know it's 360, but again, we don't want to do the math in our head. We want to be able to easily change the number of years from 30 to 15 or 20, and we want it to automatically convert that into the total number of months for that period of years. And then I'll type a comma, and now for present value, normally what I do here is I do a minus sign, and then I click on the cell that contains the mortgage amount, and then I do a closing parentheses. That works perfectly fine. That's generally the way I show you to do it in class, but I did notice that on the book, it has us putting the minus sign right there in front of the PMT. That also works perfectly well. So you can put the minus sign in front of the PMT, or you can put the minus sign in front of the mortgage amount, the loan amount. Either way will work. And the only reason we're putting that minus sign in there, either way, because if we don't have it, our resulting payment is going to show up as a negative number. So minus sign, red, or the parentheses around that number indicate that this is a negative amount. Now that's actually accurate. In finance and accounting, when you borrow money, you're receiving money. That's a positive cash inflow. But when you make a payment, that's a negative cash outflow. So it's actually accurate to show this as a negative. It's just not very human friendly to look at it that way. So that's why it's nice to put a minus sign in front of the PMT or a minus sign in front of the loan amount. So that way our resulting answer is going to be displayed as a positive number, and it looks makes a little bit more sense. Now for the monthly payment though, I am going to click on this and I'm going to show 2 decimal places so that we can really see the accuracy of this. So the house is $480,000. I put $100K down, which means I need to borrow $380,000. The loan is a 30-year mortgage at 6.7%. Therefore, the monthly payment for this mortgage would be $2,452.06, and that is to the penny accurate. Now, of course, I'm not factoring in a few things in here, like closing costs or other things that you might need to do, but generally that stuff would be added into the mortgage amount, which would therefore increase that monthly payment. So if you had like mortgage insurance and stuff like that, that could be higher because your mortgage amount might show a little bit more money. Now, if you wanted to make this a little bit more accurate, I suppose you could do that too, right? we could insert a new row in here, and we can put in other costs that are rolled into the mortgage. And I'll just throw a number down. I'll put down 5,000. We'll go ahead and do that. And then we can make sure our mortgage amount formula is going to be the house price minus the down payment plus any other costs that we might throw in there. That makes the mortgage amount higher, which makes our monthly payment a little bit higher. But the way we've written this, everything should be dynamic, and that I can change the number of years from 30 to 15, and that's going to update my new monthly payment. I'll go back to 30. I can change the 6.7% to 6.49%, and that's going to affect the monthly payment. And of course, I could say, you know what, I can't do that much down payment. Maybe I need to do 70,000 for a down payment, and of course that means I have to borrow more, which means the monthly payment's going to go up. Or maybe I'm selling another house, and maybe I can do a really big down payment of 250,000 because the equity in that other house, which means I borrow less, and therefore the new monthly payment is less. But you always want to write your functions or your formulas in a way so that you can easily change those inputs around. Now, before I go a little bit too further, I kind of alluded to the fact that we can use goal seek. For instance, let's say it is ultimately my goal, I want to have a new mortgage payment that is exactly $1,500. And just to illustrate this a little bit more, I'm going to change my down payment to $140,000. There we go. And maybe I'll change my goal here. So let's see. In fact, I'm going to go ahead and stick in a call out, little word problem. There we go. So how much down payment do we need in order to get the monthly payment right down here, which currently I have $2,100, to $1,800 exactly? How much down payment do I need to put down for that kind of thing? All right, well, that's where goal seek comes in. Now, for goal seek to work, we do have one cell that has a formula, and that formula or function is dependent upon several other cells. And the cell in question is one where we've hand-coded a number in here. I don't have a formula for my down payment anymore. So I've hand-coded a number for the down payment, and that's going to factor in. So very easy to do. Now, you don't really have to click on a cell first, but I know ultimately I'm changing the down payment, so sometimes I click on that cell first, but we can use goal seek even if we don't activate the cell. Now I'm going to head over to data, and let's see, I'm looking for, now I don't, let's see, here we go. Data validation. Nope, we don't want that one. What if analysis. That's what we're going for. What if analysis on the data ribbon and then goal seek. Now, the reason I have trouble finding that one is because I use this feature a lot on my home office computer, and for that I've got a little goal seek button in my quick launch, so that way I can just click it right up there, and I've actually kind of forgotten where it was. So I can go to goal seek now, and I get this tiny little dialog box where I can fill things out. So basically, I'm going to set cell. What do I want to do? I want to set the payment cell down here. I'm going to set my payment cell, which for me is B7. Notice the absolute references it put on there, to a value of 1,800 by changing the down payment cell. So I'm setting my monthly payment cell to 1,800 by changing the down payment cell. And when I click OK, Excel is going to go through a whole bunch of calculations, high, low, in order to figure out that I need to do a down payment of $199,924 in order to get my loan amount to the right number in order to get my monthly payment to exactly $1,800. So that is goal seek. Now, what is the total paid for this house? Well, that's going to be equal to, I'm going to do this in parentheses, our monthly payment times the number of years times 12 months per year. Now, that's all of the monthly payments. However, that's not everything you had to pay for this house. You also had to pay for the down payment. Now, I don't need to actually include the other costs in this calculation because the other costs are built into the monthly payment. So I don't need to include that. So it's just what I've got here. It's the monthly payment times the number of years times 12 months per year plus the down payment, because the down payment wasn't included in the monthly payment. That's prior to that. I press enter, and I can see for this $480,000 house, actually ended up spending $847. Now that actually number is not really that big because we made a big down payment. So the total paid wasn't as high as it might have been. I'll show you why, because the total paid will include interest, and the more the loan is, the higher the interest is going to be. Finance cost, very easy, is going to be the total paid minus the original price of the thing. So if you're going to pay for this house in cash, then you're just going to pay the $480,000. You don't need to borrow anything. But since we borrowed some money in order to buy the house, there is interest on that particular mortgage, that loan, which means you had to pay more than the price of the house. So if our down payment was something smaller, like $80,000, that means the mortgage goes up and the monthly payments go up, and now we can see the total paid is actually $1 million. So house was $480,000, but you borrowed a lot of that money in interest and paid it off over 30 years. So you really paid $1 million for this house. And of course, the finance cost is all the excess you had to pay other than the price of the house, and that was $520,000. So that is our payment function, very accurate. We know our monthly payment, we know the total paid for the house, and we also know the cost of financing. So this would be something that I could stick into in a PowerPoint. Just as a reminder, this is how we would use the payment function. Okay, now a couple other things we're working on here. So we've got our payment function down. We've calculated the total interest, which is the finance cost. Let's see, I'm going to skip on down here. I want to get right into creating an amortization table. Now, your book actually describes this reasonably well. However, it is very, very brief. They only allocate like a page or page to it. And the amortization table is not that tough, but the first couple rows can be a little bit confusing, especially if you feel like your math skills are a little bit lacking. But we're going to get through it, I know. And you actually have a participation activity, I believe, where you're going to be creating your own amortization table. So if you rely on the technique I'm showing you here in this video, I think you're going to have no problem whatsoever. Okay, so let's see. I am going to create an amortization table. Now, I'm tempted just to do the amortization table right here on this same worksheet. So I'm going to zoom out just a little bit, and I'm going to put my amortization table over here off to the side. And let's see how we want to run this. Okay, I'm going to start off here at the top, and I'm going to put in some labels for the amortization table. I'm going to go ahead and put in the payment number. I'm going to press my tab key, and I'm going to write in something like the beginning balance, and then my tab key, and I'm going to write in the monthly payment, and then the tab key, and the amount going to interest, tab key, the amount going to principal, tab key, and then I'm going to write the ending balance. And I'm going to go ahead and select these columns up here, make them all a little bit wider so that they all still fit nice and neat. And this is where we're going to have our data. So basically, an amortization table or an amortization schedule. I say amortization table, your book might say amortization schedule. It's basically a detailed listing of all the monthly payments that you're going to be making towards a particular loan. And of course, a mortgage is a loan. And so we're going to end up describing in detail each monthly payment. What is the amount that we owe at the beginning of the month? Our monthly payment is in there. How much of our payment goes to interest, finance charges? How much of our payment goes to the principal or paying off the actual loan? And then what is our ending balance at the end of that particular payment month? And since we are making 360 payments, 30 years times 12, we're going to have 360 rows here. And the ending balance, ultimately, when it all ends, is going to be 0. That's how you know you've done your amortization table properly, is when the ending balance on the last payment is 0. Okay, well, let's get to it. Now for the payment number, I could type in 1 and then a 2. I could select these two values and then drag down all the way to 360, and that would give me my 360 payment numbers. Instead of doing it that way, I'm going to do equals sequence function. How many rows do I want? Well, I want 360 rows, but I don't know that because that would require me to do math in my head. So instead, the number of rows I want is going to be the number of years, the cell that contains the number of years. I'm going to do that as an absolute reference, times 12, and then comma. Now, how many columns do I want? I only want one column here, so I'll do a 1, comma. What do I want it to start with? Well, I want it to start with 1, comma. What's my step going to be? Do I want to count by 2s? No, I want to count by 1s. So I'll do another 1 and then a closing parentheses. So the sequence function is going to look at the number of years, multiply the number of months, and it's going to give me all of these digits here. And if I could scroll down, my computer seems like it's starting to slow down a bit. I've got a little bit too much stuff open. I've got several PowerPoints and I've got my screen recorder software, so I'm always a little panicked that my computer is going to lock up on me. In fact, I am going to close all of my PowerPoints. I have Zoom going off to the side for office hours, but I'm going to leave that open just in case. All right, hopefully that'll help me a little bit. There we go. So if I were to scroll down, I will ultimately get down to 360. So it does those 360 rows very, very easily. And now, of course, what's nice about doing it this way is if I were to change the number of years to 1, then I'm going to get 12 payment numbers. Or if I change it to 15, I'm going to get 180 down there. Take my word for it. And I'll change this back to 30. So that's kind of a nice way to do this. Now, the amortization schedule is easy. It's just really, really big. Good news is we're going to be using lots of fill handle, copy paste techniques. We have to spend some time doing some work in the first row. And we have to spend a little bit of time doing some formulas in the second row. But once we get our second row done, then we can just copy everything down. It doesn't matter if it's 360 rows, 180 rows, or whatever. So we start off with the beginning balance. And our first beginning balance is going to be equal to the mortgage amount. I see I misspelled the word mortgage over there. So my beginning balance in the first payment is going to be equal to the mortgage amount. That's my outstanding debt. I'll go ahead and double click on this and I'm going to fix that. There we go. Looks a little better. Okay, so that's what our beginning balance in the first payment starts off with. Now our monthly payment is going to be easy. That's going to be equal to the calculated monthly payment. Now this one I am going to make absolute. So all of my monthly payments are going to be equal, and they're all going to be equal to the calculated monthly payment for my loan. Very, very good. Now, of course, hey, what if, don't you would recommend making extra payments? I do recommend making extra payments. But to factor in extra payments into our amortization schedule adds a level of complexity to this schedule that I don't want to get into right now. But it is certainly a smart thing to do and a good thing to do. Now we get to our first interest calculation. And it's going to be how much of our first monthly payment covers interest. And here's how we calculate that. Of course, I start off with an equal sign. Whenever you're typing a formula or function, you always start with an equal sign. My interest is going to be equivalent to my outstanding balance, but it's only based on 1/12 of my annual interest. So my interest is going to be based off of my, let's see, will I do this in parentheses? No, I won't. My beginning balance. Now, this is kind of important here. When I'm calculating the interest for payment number 1, I'm basing that off of the beginning balance. But notice I'm not basing that off of the mortgage amount. And you could be thinking, but Ralph, they're the same numbers. Why does it matter which one? Well, that's because I want to use this same formula as I move downward to the other payment rows. And in the other payment rows, my beginning balance will be different. It will be less than $405,000. So if I were to base all of these interest calculations off of the mortgage amount, then my interest calculations won't be right because the 405 mortgage amount is what my loan started with. So I need to base it off of the beginning balance for that row. So I've done that. I'm not even making it absolute. I'm going to keep this as a relative cell reference. And I'm going to multiply this by, this time I will use parentheses, my interest rate as an absolute reference divided by 12, closing parentheses. So our monthly interest is going to be 1/12 of the annual interest rate times the beginning balance for that particular month. Now, when I press my enter key, you're going to see the result of this. And it's going to be a big number, but of course it's not going to be the whole monthly payment. There we go, $21.90. So basically what this means is I send my check to the finance company that has the mortgage on my house. I send them $2,500. Only a few $100 those goes to my loan principal. Most of that $2,500 check, $2,100, is just paying interest charges. Yep. So how much will you actually reduce your mortgage by? That's going to be equal to the monthly payment for that row minus the interest for that row. There we go. So only $360 of my $2,500 payment goes to actually reducing my loan. Therefore, the ending balance in row 1 is going to be equal to the beginning balance minus the principal allocation. Now, if you get a bunch of these hashtags, that just means the number is too big to fit in the space provided. So no worries there. I can just make that column I just a little bit bigger. And in fact, I am going to zoom out just one hair. And then I will select all of these and make them all a little bit bigger. I'm going to make my payment number a little bit smaller. And you know what? I'm going to go ahead and center all of these too. I'll just do that on the home ribbon and center. There we go. So now you can kind of see. All right. Now that was the first row. Now we get to row number 2. The beginning balance for payment 2 is equal to the ending balance for payment 1. Perfect. Now the monthly payment and the interest and the principal and the ending balance are all the same. So I can select all 4 of these cells with their formulas and I can autofill them down. I'll just go one level. I'll just bring them right down here. And we can start to see what's happening. Gee, okay, so my loan started, I owed $405,000, so I pay my $25.57 monthly payment. Most of that goes to cover interest charges. A little bit of it covers the principal, and my loan is slightly reduced at the end of that first payment. And then payment 2 comes along. Payment 2 comes along. I make my same monthly payment. A big chunk of that goes to interest. A small chunk of it goes to pay down the principal of the loan, and then my ending balance is reduced by another small fraction. However, you will see, though, that my ending balance is getting smaller. And the amount that I apply to principal is actually getting a little bit bigger. So the first payment, only $366 went to principal. In the next payment, $368. In the next month, it's going to be bigger and bigger and bigger. And of course, my interest allocation gets smaller and smaller because remember, interest is based off of the beginning balance for that month. And if my beginning balance gets smaller and smaller, my interest will get smaller and smaller, which means my principal will get bigger and bigger, which means my ending balance will reduce at a faster rate by the time we get to our 360th payment. Good news is, now that we have row 2 done, I can select all the cells in row 2, all these calculation cells. I'm going to go to my fill handle and I'm going to double click 1, 2. There we go. And that completes the amortization table. Now, to know that I'm successful, I'm going to scroll all the way down to the very last payment, and I am looking to see a 0 ending balance for the last payment row. And I scroll down, and there we go. I've got a 0 ending balance for my last payment. That's how you know that everything is correct. And it won't be off by a penny. It won't be off by $1. It will be 0. All right, so that is our amortization table. Should just be pressing Control Home to go right up to the top. And of course, since our amortization table is based off of information over here in our payment calculation, we can change all of this, right? So I can go to the house price and I can say, no, this house is going to be $550,000. And my down payment is going to be $110,000. My other costs are going to be $11,000. And instead of a 30-year mortgage, I'm going to do a 15-year mortgage. Instead of 6.49, I'm going to do 5.99%. I can see the changes in the monthly payment. I can see my total paid, my finance cost, and if I look at my amortization table, everything's going to be up to date. So if I scroll down, now some of my columns are a little bit too small, so I'll just go ahead and auto-fit those. And I can see, oh, I scrolled down a little bit too. Oh, that's right. Here's what's, no worries here. So basically, my 15-year mortgage stops at payment 180, and you can see my balance does 0 out there. Don't be put off by the parentheses showing a -0. The only reason you're seeing that is because if I were to show more decimal places, you might see a number over there, but rounded, it's 0. And we can see, okay, with a 15-year mortgage, we pay it off after 180 payments. Now, of course, you wouldn't really keep making more mortgage payments after that, but my amortization table goes all the way down to 360 rows. So that is the gist, but it's still a completely accurate amortization table. All right, well, that takes care of that phase of this particular activity.